So in this video, we're going to be working with complex numbers, right? Everything that we have been doing in this class, we have been using real numbers. That means that there's a solution on the numbers that we know, that we can count, that we can, right? In this case, we are going to be working with numbers that are in the imaginary part, right? So for example, we know that every time that we square a number, that has to be positive. So there's to be a way to write in this solution, right? So I'm going to do exactly the same as if that number was positive, right? But in this case, so this is going to be a plus or minus. The square root of 16 is 4. Because I'm looking for the square root of negative 16, that's not a real number, so we have to express it as an imaginary number. So the only thing that we're going to do right here is to add the I. Why? Because the square root of negative 1 is the same as I. So I can express it like that, right? Let's remember that a little bit later that we're going to use it in another exercise. Right? So my next one, I have the square root. I'll take the square root on both sides. X equals, in this case, again, it's negative 47. So because of that negative, I'm going to take out, first of all, plus or minus, and I. And the square root of 47. The square root of 47 does not simplify, so we just keep it like that. Okay, the next one. Again, my first step here is that I'm going to divide by negative 4 on both sides. So a squared equals negative 10. The same square root on both sides. So a equals plus or minus I square root of 10. Okay, here again, I'm going to divide by negative 2 first. So m squared equals negative 49. And the square root of both sides. So m equals plus or minus 7i. Okay, now I can treat the I as a variable, right? And I can do operation with it, right? So my first step here is that I'm going to distribute that negative over here. So I have 4 plus 3i minus 6 plus 7i. Now I'm going to add 4 minus 6, or subtract 4 minus 6 is negative 2. And then my like terms are 3i and 7i, so I have plus 10i. See, when we're writing complex numbers, we're always going to write the real number, the real part first, and then the imaginary part, so the part without the I, and then on the right, the part of the I. This is very important because every time that I write a complex number, I'm going to write the real part first plus the imaginary part. This is a complex number. This is my complex number. This one again. So this one, because this is positive right here in the middle, I don't have to distribute. So I have 7 plus negative 4. So that means that I have 3. And I plus negative 8. So I have negative 7i. That's it. Next one. As you can see here, I'm multiplying two binomials, if you want to say it like that. So I have two FOIL. So that means that I'm multiplying the first two terms. So positive 30. Now I'm multiplying the outers. So negative 48i. The inners. So negative 10i. And now the last. So I have plus 16i squared. Right? Remember that we said that the square root of negative 1 equals I. Right? If I square on both sides here, I have that I squared equals negative 1. Right? So that means that I can substitute here I squared for negative 1. Every time I have an I squared, I can substitute it for negative 1. So I have 30 minus 58i. I just combined those two like terms. Plus 16 times negative 1. So I have 30 minus 58i minus 16. Now we can combine this like terms. So 14 minus 58i. So I have a square, so I can express it as negative 6 minus 8i times negative 6 minus 8i. So I'm going to multiply. So first. So negative 6 times negative 6 is positive 36. Negative 6 times negative 8 is positive 48i. Negative 8i times negative 6 is positive 48i plus the last 64i squared. Again, so 36 plus 96i plus 64 times negative 1. So I squared is the same as negative 1. So 36 plus 96i minus 64. So this equals to 28 plus 96i. Now, to graph each complex numbers, as you can see, I mark my x-axis as real and my y-axis as imaginary, right? So I'm using my x is the real part of the complex number and the y is the imaginary part. So actually on this one, I'm going to graph the point 4, negative 2. So that means that I'm moving 4, 1, 2, 3, 4, and 1 and 2 down. So I'm marking this point right there. So this is the point 4 minus 2i. So the next one, again, I have 2 and negative 2i, so that means that I'm graphing 2, negative 2. So 1, 2, 1, and 2, and that's the point 2 minus 2i. Okay, now the absolute value of a complex number, the absolute value, right here, copy this on your notes. So the absolute value of a complex number equals the square root of a squared plus b squared. So that means that I have here my absolute value here is going to be the square root of negative 8 squared plus negative 10 squared. As you can see, I'm using right here parentheses for that negative, right? So I'm using parentheses for that negative because I want to square the negative 8. When you place it on your calculator, be careful how you write it on your calculator, right? Because if I just write negative 8 squared, it's going to have it as a negative, right? So in this case, I know that this is going to be positive 64 and positive 100. So this is 164. So this is the same as the square root of 4 times 41. So it's 2 square root of 41. Next one. So again, A is 9, B is negative 7. So this equals to the square root of 9 squared plus negative 7 squared. So I have 81 plus 49 equals the square root of 130. That one does not simplify. That's it. Now, when I'm simplifying, I have a imaginary number on the denominator, as when we have a radical on the denominator, we want to cancel out that right there. So we're going to multiply then what is called the conjugate pair. So in this case, the conjugate pair, as you can see, I'm just changing the sign to its opposite, the one that is in the middle right there. So its conjugate pair is going to be the same, but the imaginary part is going to have the opposite. So 7 minus 3i, its conjugate pair is 7 plus 3i, right? So I'm going to distribute, so I have 35i plus 15i squared divided by 49 plus 21i minus 21i minus 9i squared. As you can see, I cancel out this part right there. So 21i minus 21i is 0. So I have 35i plus 15 times negative 1 divided by 49 minus 9 times negative 1. So this is the same as 35i minus 15 divided by 49 plus 9. So remember that we have to rearrange on top. So negative 15 plus 35i divided by 58. Again, so here, I'm going to multiply times conjugate pair. So 1 plus 10i, 1 plus 10i, right? So negative 10, FOIL here, I'm FOIL here. So the first negative 10 minus 100i minus 6i minus 60i squared divided by 1 plus 10i minus 10i minus 100i squared. This cancel out. So negative 10 minus 106i minus 60 times negative 1 divided by 1 minus 100 times negative 1. So this is negative 10 minus 600 is I plus 60 divided by 1 plus 100. So 50 minus 106i divided by 101. And that's it for this lesson. May the force be with you.